Monk robs dragging through the city's heat haze. Dodging sirens, wisdom sharp as switchblades. Concrete jungle got the temples I invade. Seeking inner peace while the outer world fades. Meditation in the chaos, third eye sharp. Urban monk, where the wild serenity sparks. Breath control steady, lotus pose in the dark. Chasing nirvana even where the shadows bark. Hustle bustle echoes, the mantra beats deep. Silent in the storm, my discipline steep. Karma on the corner, debts I don't keep. Seeing monks rise where the street lights weep. Clarity sharp, cut glass through the tension. Pocket scripture streets my meditation session. 808's cutting, heartbeat ascension. Balance in the grind, my daily confession. Zen in the alleyways, graffiti of scrolls. Mind state untouchable, diamond cut goals. Steel-toed truths, walk paths where wisdom rolls. Urban monk vibes, my crown of pure gold. Meditation in the chaos, third eye sharp. Urban monk, where the wild serenity sparks. Breath control steady, lotus pose in the dark. Chasing nirvana even where the shadows bark. The mantra beats deep. Silent in the monks rise where the street lights weep.
All right. Almost ready. Gotta get a little coffee in my system here. Oh my god, microphone is so sensitive. All right. Oh, there I am. Welcome. We're gonna do some programming today, and a very special kind, actually. I was looking, I don't know what's going on, other than this is a website. Anyone can access this. It is located here. So this, you make an account and you get to play around with some of these. in this case a CodeBot. We're gonna take a look at what we are working with here. It looks like a little mechanical RC car, but souped up with some electronical firmware. And I believe this will be the future, boys and girls. We're gonna live in a world where coding will be the main interaction between us and technology, if it's not already. Although we're so used to computers, coding our PCs, coding our general, I don't know, computer programs you create. I've made browsers, I've made calculators, I've made games, I've made all kinds of things and taught students how to do these as well. But in the future, we're going to be seeing a bit more interaction with our real life objects, whether it's a Roomba, a drone, anything that could particularly take in code and instructions based on a set of Python, I would say would probably be the main language of choice in the future. Though I have seen JavaScript entering a lot of firmware based locations because it's such a popular language. It has become a go-to alternative to Python. In the case of the Flipper Zero, the little device, where's it at? This little guy. It used to only do basically assembly and small C programs, but they've updated it to actually work with JavaScript, and it can access the hardware inside, aka the pins on the top, so you can essentially connect external devices wire by wire and then use JavaScript to control the device, whatever you're doing with it. I've got an example here. A couple, if not many. Yeah, one thing. Oh yeah. Where is it? I got a whole box of little. Nope. A little loud. God, there's so many things. So we've got little LEDs, of course. And this one. See the pins on the bottom? It's gonna be a little bit tricky to show. Yeah, these pins will connect, not directly like this. I would have to actually port it through a breadboard, but it will connect in essence with the pins onto the flipper, and then we can program that. Now, what is this? This little piece of hardware is basically a sonic distance measure. Think of like a bat. A bat can measure distance and location based on ultrasonic frequencies, and basically those two speakers we saw, one of them sends out a signal, a ultra high frequency that you cannot hear, and the other one accepts it back. So the echo is the measurement of how far something is. Though I believe it's about a 2-meter or so distance. Now, I'm not much of a hardware guy, though I've been dabbling lately. I've got buzzers, motion detectors, torque identifiers, magnetic field. Okay, cool. Little guy here. These are basically little modules you can get online from like Amazon or so. Inside of here, there's a little top part here that will measure magnetic resonance words, and you take in information from the pins. You decode them, figure out what they mean when you're doing the debugging, and from there, well, oh no, I'm making a mess. Oh, hold on. Oh. And from there, you can use code to identify details and probably make it do things it's not generally meant to do, I would suppose, if you found little hacks around stuff. But hey, we're starting small. We're gonna start with this. Make that for real labs.com. And we're going to be using this to essentially learn how we can use Python to interact with objects, with electronic objects, with objects that basically give us direct pin-to-pin interactions. We can move tires, we can make it churn, all kinds of little bits and pieces like this. So that's the goal here. And again, it's the first time I loaded it up. I did a tutorial on how to work things through, so let's get moving. Let's learn together. I'm normally a software type of guy. I make a program in Python, whether it's an AI script, a RAG, or some sort of top level Python script that'll use a AI server, let the AI access the internet through the Chromium, the web Chrome driver, whatever it's called, the V8 engine, and basically pull data from the website and then let the AI read data. So if the AI essentially needs to get more detail from the web, it'll have internet access through my script. So I'm mostly software as far as anything, and servers and things like that, networking type of connections. But here we're entering a new space, and the space is hardware. So let's take a look here. So CodeBot is a computer on wheels and lots of sensors and controls built in. You'll be writing Python code to bring this hardware to life. Computer's peripherals provide input and output, I/O, for your code. Some of the CodeBot's peripherals are line sensors, proximity sensors, wheel encoders, push buttons, and infrared receivers. Well, each one of these has a purpose. Each one of these will give some sort of data to the CodeBot. So proximity will measure how far certain objects are from the CodeBot. The wheel encoders will essentially give us the ability to rotate the wheels in a particular speed, rotations per minute, second, whatever we decide. Push buttons, I'm not sure about, but we'll figure it out. And infrared receivers, taking control from some sort of remote device. All right, so there's our little CodeBot here. Motors, programmable electric engines. CodeBot motors power the wheels and move it around. They convert electric power to mechanical rotation. The picture at the right shows a motor without its protective black cover. Right, that's be the inside. I'm assuming this is an actual object you can get online. But this is what each wheel is attached to. Normally this is just a typical electronic motor connected to a wheel, and that wheel will rotate based on our... Cool, great. I love when everything beeps. Hold on a second. There we go. This microphone is so sensitive. It'll rotate this engine by providing a sense of, or a source of power, and based on what we coded or how fast we coded, the amount of power will be translated through the firmware. You'll soon be controlling these motors with Python code. Locate the motors in 3D view and click on one of them. Okay, all right. So right there, it's a little bit of a motor there. Continue. All right, so we've identified where it is. Get the motors running. That's a differential steering, also known as skid steer. You'll be steering CodeBot with those same motors, so you can kind of turn on one and turn off the other, so it's steering in one direction, or reverse the power of the on and off based on that. So you can also do these turns with different amount of power in each. So if you want to turn right, you would provide more power to the left wheel and reduce the power on the right wheel, so it'll overpower the direction towards the right. Okay, great. Objective 2. LED. Light emitting diodes are tiny and efficient electronic components that produce light. There are 17 visible light LEDs on CodeBot, and there are 8 more LEDs that emit infrared light only robots can see. Cool. Like everything on CodeBot, that's pretty much do nothing. They pretty much do nothing. until you write some code, of course. You'll be doing that on the next mission. Up close LEDs look like a little clear boxes. So all of these are little teeny tiny LEDs. If you ever see them on a circuit, remote control, if you like to take apart technology, this is a key factor. You take apart some stuff and you can look inside, and you will see these particular diodes, in essence, directly integrated into the motherboard. They don't really look like they are much, but they do light up. Zoom in. Okay, let's find these little guys. Where we got at? Oh, right here. Alright, 7, 8. Ooh. Okay, alright. Hello, CodeBot. How are you doing? Alright, so we got 0, 1, 2, 3, 4, 5, 6, 7, 8 of them. Always remember, computers count by the starting point of 0. Alright. Next, speaker. Make some noise or make beautiful music. It's your choice. I highly doubt this will make much music. There's a real speaker aboard your bot. Inside this little black cylinder is an electromagnet with a permanent magnet to pull against. Okay, so just a typical speaker working. Hey, that's basically what's going in the motor too. Electromagnetism. Love it. All right, what are we doing now? Click the speaker. Yeah, it's right here. So we got a cute little speaker. Boop. Okay, great. We're identifying all the components. Sound off. I look forward to hearing what you do with the peripherals. Great, thanks. Alright, wheel encoders. Your code can control the power, there it is, applied to the motors. But to know exactly how far the wheel have turned, you need to sense rotation. That's the job of these encoders. As the encoder disk rotates, an invisible IR infrared light beam passes through its slots. Okay. Hold on. This is distracting now. There we go. Alright. As the encoders rotate, so we need to essentially manage these encoders to modify the speed of each wheel. Click on the black encoder disks in the 3D view. There it is. Okay, so it's right there next to the motor. You can see that little circular fan-like disc. Precisely done. The encoders enable you to create a feedback loop in Python. Alright, you'll learn how to engineer cruise control and code. This ain't just theory. Well, it's a control system theory put into practice. It's a game theory. Alright. Push. Excuse me. Oof. Talk on my own spit. Push buttons, line sensors, proximity sensors, accelerometer, and more. Okay, last objective for this intro mission. Then we start coding. As you see, there's a lot happening in your CodeBot. You'll explore all of it by writing code to complete missions. And you're gonna need all those capabilities for the challenges we have in store. Great. Complete this objective by clicking on the CodeBot button. Button. Where is a G button? No button. Oh, so many buttons. Hold on. Which one did it want me to click? This one? Yeah. We got buttons. Ooh. Battery to USB. Interesting. It's pretty cool. Oh, there's an actual USB. Right. Oh, hello. We can plug you in and make you big and strong. Okay. Hey, you're pushing my button. Sorry, but you walked into it. Okay, great. Okay, cool. Log into CodeSpace. Click login button. That's it though. Light the way with Python code. Alright, now it's about time to turn them on. In this mission, you learn how to write a simple Python program. We're starting from the basics. Use Python library to access pre-written code in the import function, and use the CodeBot LED functions from the bot core library. And turn on all 17 of CodeBot's LEDs. Hold on. All 17? I only saw 8. You may have heard about the concept of a hello world. That's traditionally the first program you write when you learn a new language. But what about an embedded system like a robot that has no text display? Yeah, blink an LED. True. Yes, a single LED may not seem exciting, but from such humble beginnings, massive starships are built. So here's your code. Okay. So we're going to take from bot core and we're going to import everything. That's what this asterisk means. It's a wildcard for basically every little library piece of file. Now, how, and we're going to go into detail. I like to go into detail when I do coding. So we're going to take our time with each line from here. Bot core. It's potentially a whole library specific to this device. Every device will have a different library, different manufacturers, different products will have different ways to basically use specific lines of code, or they have their own library of code. Here, we're importing bot core, or from bot core, we import everything. Unfortunately, we can't see what's inside. So we kind of have to go to an online documentation, look at all the possible imports we are actually importing at the moment. But in a due respect, we are going to be using these directly. So what I'm seeing here then, from your typical, Python code, you have standard functions, standard pieces of code that will work without any imports. But from here, I see that we have something now called LEDs, user num, and we're going to turn on the 0 LED to true. That's what's happening here. LEDs is coming from import, from this asterisk. So we should be able to not only just import LEDs by itself, we can just basically put LEDs here, and that should still work. Right? But of course, this is trying to basically... Hold on, unexpected indent. Oh. Python's very sensitive. Oh, what am I doing up there? Python's very sensitive to spacing, so careful. Okay, so there's 0, right? We've imported just LEDs, but because we're going to be doing a much bigger set, I'm just going to do this. Let's do a couple of things, right? Let's play around with this. We're going to go ham. We're not just going to do a simple thing here. And then we run it. Bam. All of them are turned on. Well, what else can we do with this? Well, first, let me show you what happens, right? We can take this LEDs and change it to asterisk, which means we're not only just importing this LED class object, but we're importing everything alongside it. Probably the motors, the speaker, everything that's involved in this device. So me changing this to asterisk will not change anything. I can just kind of do a false here to show you that. We will adjust now. One of these is turned off. That's 3. And then from there, we can have some fun. Let me see what I can do here. Let's say while, or let's do a loop. I love loops. Loops make things fun. Let's make a loop that goes about 100 times. Loop equals 100, while loop is less. No, we need another variable to keep track of the count. So we'll call this L count. Loop count equals 0. So while L count is less than 100, now my big question here is, can I use zeros and ones? Because that'll make things a little bit easier to kind of adjust mathematically. But we can still play around with the true and false also. So we're going to loop this about 100 times. However, it's not exiting. So we could do a couple of things here. If L count is greater than 100, break. That gets us out of the loop manually from the inside. But also, if L count is less than 100, the while loop itself will leave on its own. So necessarily, we need one of these. Now notice L count is not changing. So we're here in an infinite loop. It will actually never stop. So what we have to do is do a adjustment. That adjustment, just increment L count every time we pass the loop. Oh, JavaScript habits. So now with this line, we actually change L count to increase by 1 every time the loop ends or gets to the line 21 here for the ending case. Now, nothing's actually happening yet. There's just going to be the same lights over and over and over. So let's see what we can do with this. I want to kind of make them maybe flash or do some random animations, have a little fun with this before we move on forward. Otherwise, we're basically done. Like, step 1 is basically done, right? That's all I have to do. I'll open the code tab to learn more about your code. Oh, there's another thingy. Where's that thingy? Where's the little man running? Where's the little man? Little man. Open the code track to learn about your code with the dot button. Okay. Well, if I ever find it, I'll click it. At this moment, I'm a little distracted. Where is that little dude? Okay. So I want to change this. Ah, here's the thing we can do. Let's see. So, well, first and foremost, we can basically do a quick count, right? So I won't need all of these. Boom. But we can do count just to basically turn them on one by one. So what this is going to do is going to start from 1, go forward, and each time we get 0, 1, 2, 3, 4, 5, it's going to increment the lights. Now, it did say there were 17 lights. I don't see 17 of them, but we're about to find out where they are. Now, let's do it. 0 to 7. Okay, so the range is 0 to 7. So here's how we can modify this case. We can say, all right, if count is greater than 7. Wait a minute. We can do it quickly. We can do a modulus. We can do a mod 7. So this will take 0 mod 7 and it'll return 0. Then it'll take 1 mod 7, it'll return 1. As soon as we get to 8, it'll do 8 mod 7, and modulus basically divides two numbers together and returns only the value remainder. Right? So in this case, we're actually straight up just returning whatever is remaining. Now, how many times things divide? So like 16 divided by 7 would be 2 with 2 remainder, aka 7 times 2 is 14, and 16 minus that 14 is 2 left over. What this does is restrict our values to a maximum. This will actually never go beyond the number 7. Every time we go through a multiple of 7, it goes straight back to 0 and starts over again. Okay, so that was really quick. Maybe I gotta do mod 8. Yeah, mod 8 maybe. Okay, so there's all of them. Now, well, that was really quick. Let's see. There's a sleep form here. 5. Is that gonna work out? Is this a default? Okay, there we go. So every 5 seconds. No, it's not sleep. I gotta do time.sleep. So I think I gotta import time and then do time.sleep. I think. If that's the right import. And I'm gonna change this to 1 second instead. I'm gonna have to figure it out. Okay. Yep, there we go. 1 second, new light turns on like a boss. Cool. So in this way, we can control each based on a time synchronization. Now, it's great to have time when you're trying to do some sort of slowdown, because a computer thinks thousands, if not millions, of instructions per second. So you saw how without time, it basically just like turned all of them on, even though we went through a loop. Right? Cool. So I do that, and then all of them turned on instantly, because there is no slowdown. The computer thinks really quickly. So what we're really doing is just slowing down the processing time with a sleep command, so we can actually see the changes being made. Now, my question is, how do I identify whether it's true or false? Which I will need to do a little debugging. In debugging, we'll need a console. Okay, CodeSpace Python. Interesting. So it's like a custom Python. Well, what I can try and do is try and see if I can look inside of LEDs. So I'm going to print str LEDs and see what pops up. Hopefully something useful. No, it's just an object. Okay. Okay, okay. What about if I do user LED.user num? Let's see if that returns anything useful. That's a method, bound method. Okay. So basically all we're doing here is accessing or printing out information from the inside. Now I can actually go into like the documentation, try to figure out all the particular pieces to LEDs and go through a bunch of text, but I like to black box things and learn them as I basically use them. So right now, LEDs.user num is giving us a method. Okay. Can I just basically put 0 and will it tell me if it's true or false? If I can figure out how I can activate and identify whether one of those LEDs is turned on, no, that's not going to work out. It's a different function method overall. All right. So what about LED num? If I was a developer, that's what I would name it. Nope. No object num. Okay. Debug data. Okay, well, there's got to be. Let's go to help. Let's go to class dashboard. Class dashboard. Let's go to class dashboard. Let's take a look at where's my classes. You don't have any classes. Okay, no, this is a custom class based location. Okay, let's go to Free Labs documentation. All right, primer Python modules. We want to go here. Let's find LEDs. LEDs. Gallery colors, canvas, Python modules. Okay, radio, all that jazz, bitmap. Let's just do LEDs search. LEDs, Python class, yes. There it is. Okay, so get the current brightness of an LED. Oh, we can change brightness to get status. That's what we need. All right, so that means I'll do a LEDs get status of 0. No, that's not it yet. Object has no attribute get status. Get status. Get the current brightness of LED. Okay, set num and brightness. Set the brightness, set mask, set status. Okay, well, all right. Well, this one is user num. Let's find where the appropriate user num functions are and see if we can find anything related to that. Okay, bot core. Okay, bot core, CBLEDs, user num. Let's look around here. Expansion encoders, line sensors. Okay. So this is a special bot core based system. What we saw before was code air hardware interface. That's something different then. So we got bot core, but I was in code air, so I was in the wrong. This is the thing about documentations. Make sure you're in the right place. So let's see, bot core speaker system next. Bot service and can I just like do CodeBot LEDs? Let's see. CBD, CP3, bot core, hardware interface LEDs. Okay, maybe. Okay, CBD LEDs. Okay, great. This is us navigating the masses of documentation. So ls num, ls emit. All right. Prox. User. Set all user byte LEDs to given binary interval. Okay, user num. Set single byte. Okay, so this is the one we were using now. The number value of the LED and then the value of, oh, look at that. Okay. 0 to turn all off, 255 to turn all of them on, alternating in hexet bytes. This is in bits. Zeros and ones turning on and off each, or you can throw in a array of trues and falses. Okay, great. Can I figure out how and what those particular read to give an analog encoder? No, we're doing encoders there. So all user bytes to the given binary. Trying to find out how we can actually read what each individual LED is. ls num. I can do it manually. Technically, I can keep track of it manually, but I'd rather use some sort of internal bit. Set all user line sensors marked. No. Okay, so I think I'm gonna have to do it manually. Set USB LED. USB is on. Oh, set parameter is turned on if true. Oh, wait. Is on. USB is on. That sounds like a question based on is it true or not. But that's inside of the USB method. Is on Boolean. Set USB LED user. Set all user bytes be into the LEDs from 0 to the given binary integer value 2 bools. All right, well, you know what? I'm still new to this API, so let's manage this manually. So the way I can do this is as we go from each individual value, we can do LED array equals to bada bam. And then we can basically set, I'm wondering if I have to actually allocate each one of the places, but I feel like I can just basically say the current LEDs array of, let's adjust this. So let's do L count, take this out, the current LED equals to the L count mod 8, so we can simplify our coding. This is how you refactor to make sure that when you're working with specific repeating code, you're not constantly doing the same basically math over and over. It simplifies the processing, so you don't have to do the math. You don't have the computer doing math constantly. You just do it once and save it for later. So the current LED is based on the L count mod 8. The modulus is dividing by 8, and if we get a division of 8 with a remainder, the remainder is the piece that gets saved. That's a little bit, again, mathematics here. This is why I like to teach both math and programming. This is where like the actual mechanics and power of programming comes in. It's the combination. You don't have to necessarily be math crazy to be a programmer. I mean, generally speaking, you can be more like a web developer, right? You don't have to have that math concept. But when you get deeper and deeper into hardware, definitely the case. So let's kind of get some examples here, right? So if I do the mod, right? So let's say our L count mod 8, right? What's that going to be? So if our L count is 0 of mod 8, remainder is going to be 0 because there's nothing that goes into it. We'll kind of skip because, I mean, if we get 1 mod 8, that'll equal to 1. Nothing crazy happens here. You can skip to the end and say 7 mod 8, still going to be 7. All right, but then when we go to the next digit, 8 mod 8, well, 8 goes into 8 once. Clear that out. In division, you have nothing remaining, so we go back to 0. What about 9? 9 mod 8, spacing, 8 equals to 1 because 8 goes into 9 once. Subtract 9 from 8, that one time it goes in. This is just base division. And once you subtract that one time it goes in from 9, that's 9 minus 8. You get 1 left over. And then 10 mod 8. Well, 8 goes into 10 once. Subtract the 8 from 10. You have a remainder of 2. And you can see then basically all we're doing is creating a repeating value that will continuously repeat between 0 to 7 based on the fact that we're using mod 8. And then if I go back to mod 8, 15 this time at the end, I'm kind of skipping some numbers here because the pattern starts to make sense, right? So if you have 1 mod 8 is 1, 2 mod 8 is 2, 3 mod 8 is 3, all the way to 7 mod 8 is 7, then it starts to change. 8 mod 8 is 0. The repeat begins. 9 mod 8 is 1, 10 mod 8 is 2, 11 mod 8 is 3, 15 mod 8 is going to be, well, 5, 15 minus 8, subtract, you get 5, 6, 7, 6, 7. I have enough students to have to constantly remind me of 6, 7 on a daily basis when I'm teaching them, so that's literally programmed into my brain. I'm actually using it as a entertainment factor is kind of fun. Keeps students attention span. And then 16 mod 8 is going to be basically 8 times 2, right? 8 times 2 is 16. Then you subtract the amount of times 8 went in. It went in twice, so that would be a total of 16. 16 minus 16, back to 0. So there we go. And finally, we can kind of get a little more example here. 17 mod 8 is going to be 1. And you can kind of get the pattern here, right? 18 mod 8 is 2. And then we keep going. So that's the concept here. I'm skipping a few values here. And skipping a few no, was here? Right here. And I'm skipping some values here. But you're starting to see the pattern. Modulus is a way that in mathematics we divide, but our concern is not how many times 8 goes into a number. The answer in the quotient, the top of the divisor, right, would be 16 divided by 2 is 2. Divided by 8 is 2. 16 divided by 8 is 2. That would be the quotient. That would be the amount of times 8 goes into 16. Our concern is not so much how many times it goes in with the modulus, but what's left over after we go in. So 16 divided by 2, or by 8, I keep dyslexing that in my brain. 16 divided by 8 would be 2, but that would be exactly 16. And we subtract 16 from 16, our output value is actually the 0 remainder. Important to consider here. So that's what's happening. And all we've done is basically said, hey, there are 8 LEDs. I don't want to go up beyond the 8th value of how many LEDs I have on this particular CodeBot. And based on that mod, I'm going to account for each one of these being a LED value. So we're just going to go from 0 to 7 over and over and over as we're counting to 100. And I'm going to start doing a little manual, what's the word? Management, I suppose, a management within my code to keep track of whether a light is on or off, because I was trying to find the documentation, if I can check and see if a certain light is on or off, but either I'm not finding it or it's somewhere dug deep, and I love documentations, but if I can do it manually, I'll probably do it manually. Okay. So now from here, I have a LEDs array, ARR array, and an array is basically a set of numbers and values that are attached to a kind of big, like if a variable, right, is a box, and we put numbers in a box, like x equals 5, we take a 5, put it in the box, now it's x, and we say x is 5, or inside a x box, the label x is the number 5. Well, an array is basically having a bunch of these boxes on a shelf. Each box has a different value inside. So I can like to consider very regular variables, single storage variables, like just a typical x equals, like loop equals, right? Loop contains the number 100. Get a box, put a loop label, right, loop on it, so you know what's inside, and then put the number 100 inside, and now boom, there's your loop equals 100. Well, LED's array as an array is basically a shelf. Cat, my cat's going crazy. Relax, bud. A LED's array, or just a general array, is basically a bunch of variables on a shelf. A box, a box, a box, a box, a box, a box, and we go through the boxes and check what's inside. I have other videos on YouTube recorded based on basics in Python programming, JavaScript programming, C programming. So definitely check them out if you need more specific detail to what arrays are, what variables are, how loops work. We are using loops, so we are technically in the beginning spaces, but we're also not going into full detail on how to manage loops. That's with the other videos in my YouTube at ChrisMIA. So make sure you take a look at that. I'm trying to move around a bit. YouTube's acting funky. I used to have a good amount of viewers and people coming in, especially on lives when I was doing programming, and then they changed something probably like 2 or 3 months ago, somewhere August, and things just didn't work the same. So that's why I haven't really been streaming too much. I'm just figured out a better way to multi-stream across multiple places. I'm on Rumble, still on Twitch. I don't pay attention to Twitch too much. A lot of bots and shows out there trying to sell stuff, so I'll put it on there just for the case of anyone that's interested in this stuff finds it and wants to follow forward. But I recommend you potentially go on YouTube for now, but I do have the Rumble that I'm working on, right? So Rumble is going to be potentially where I'm streaming from right now, and it's multi-streaming to other locations. So I have my X at TWL. Let me change that real quick. Let me give you some of these links so you know where to find me. So we've got x.com at TWL Christoph, youtube.com at ChrisMIA. I forgot what Rumble is, but it should be the same thing basically. There's two ways to connect on Rumble, I suppose, because they actually treat users and channels differently. So on Rumble, you can find me at Crisis0 as my user. Feel free to follow me. Feel free to interact with me there. That's always fun. Great to meet new people when they're exploring these kind of things and find interest in these things. But then my content... Verifying I'm a human. Yes, I am a human. Thank you, please. I are human. Oh. Really? What do you mean? I literally am signed in. What are you talking about, bro? Oh my Jeebus. Jeebus. Oh, good little mental break at least on doing this kind of stuff. Let's see what the music's playing. Let's kind of take a mental break. Give you a moment to look around a bit. Oh, I signed in. How did I sign out? ¿Dónde? ¿En qué pasó? What happened? I don't like how I can hear myself. That's one thing I don't like. But I don't like how I'm literally... Everything is being heard. This microphone is insane. I need to figure out how to work that out and stuff. Ah, is it? Oh, I don't have a special one on Rumble yet. Ooh, true. It's just this mess. Okay, on Rumble you can find me this way. If I get enough, what's the word? That's my channel, right? Rumble channel. If I get enough followers, that's kind of out of the way here. There we go. So if I get enough followers on Rumble, I can actually customize the channel name. So like and subscribe on any platform you like. I would prefer Rumble for now. I feel like Rumble is a pretty good alternative to YouTube with all the chaos happening in the YouTube space. So keep that in mind. I'm gonna put this above in my head. Somewhere up here. Like that. Oh, looks weird. Looks weird. But anyway, I don't know where I'll put this, but it's here for now. Yeah, I'm trying to expand on basically streaming a bit more, doing more of these sort of learning processes here, how to code, how to start. Try to be as detailed as possible, but if you do go to my YouTube, you'll be able to find a ton of videos based on not only Python, but C++, JavaScript, PHP, MySQL. I think I have some in there, maybe kind of. I think I have to make a few more on those, but that's more like database management versus just regular coding. Data can be a bit more nuanced and intimidating. So I'm taking my time with the MySQL type stuff. But it is for beginners. It's for beginners and advanced. And in the end, this is not my full-time thing. I am a very super small, tiny man in YouTube. But if you do need help, if you have the passion to learn, but you just haven't figured out where to begin, try out my Patreon, right? If you go to my Patreon, right, you can basically look at a lot of stuff. I'm all over the place. My ADHD is insane. I do a lot of market analysis as well, because I do not only teaching in mathematics and programming, I do trading. So I'm always keeping up with latest things that are happening. Currently the AI bubble happening, so that's exciting. YouTube also going a little crazy. Yeah, AI is going crazy in YouTube. AI is breaking things, basically. AI is breaking a lot of things. But anyway, if you do need help, try joining free. If you join free, you basically can come in, have communication with me directly. And if you are ready to basically get started, need someone to help guide you through the beginning steps, basically you want remote help, there's a couple of ways I can help, right? As far as options, you can get hours of remote one-to-one sessions where me and you connect, basically like this right here. Just like basically you see here, right? I'll be in this little corner and you'll be on the other end asking me questions, and I'll show you whether it's mathematics, whether it's programming, everything in that case scenario. We basically do this on a personal level, not just me broadcasting to the internet, which I prefer broadcasting, because in the end, if I can teach more than one person in 1 hour, because I'm used to doing one-to-one sessions, right? So I can only teach one person, which is a much more personal, customized experience where that person, that student, can ask me questions that concern them. So I'm able to address them directly and really move the scales when learning may stop someone from continuing the progress. Getting over the speed bumps, really much easier and smoother in a one-to-one session. But personally, because I do one-to-one all the time, I basically love to see when one of my videos has more than one view, because that tells me that same hour that I took to make that video, or that same hour I took to teach one student, is actually benefiting multiple students. And that to me is scale, right? If I'm able to enlighten and teach more than one person in a single hour, that makes me happy. And in YouTube, pretty straightforward. But when it comes to like one-to-one, there's no replacement for it, right? Having the ability to ask me directly, ask me questions that I can answer directly. I kind of wanted to do something like this too when I grow the community a bit, with people that are more interested in learning, and starting basically online streams where we can all gather together, go live at the same time. I'll have people call in and ask questions, or type messages and ask me questions in chat, stuff like this. That would be perfect. If I can get that sort of interaction, that would be absolutely amazing for me. I would love to be able to help more than one person at one time in 1 hour. But if you do need essentially help, consider getting an hour, like a 1 hour live remote tutoring session. You can get 2 for 50, you can get 4 for 90, and it kind of goes down from there, right? If you need more hours, it goes down and down and down. Now, if you don't need hours and just need someone to talk to in case of advice, help, guidance, text message, send you a picture of what your issue was, like you send me a picture of a problem, maybe a math problem, and then I can go in with that picture, mark it up, show you what to do where, and then send you it back. That's it. That can be basically a $7 a month thing, right? That's not even the case for like having to be on a one-to-one session. You just have that, hey, I have an issue with this problem, here's a picture, what do I do? Or I got stuck here, where do I go from here, right? And then I can respond. In the end, we all got to work. We all got to do something to make the ends meet. So these are the kind of things that I support in my students, generally speaking. My Patreon is kind of my personal place. I do also work at other locations that have students, so that's why I'm not really streaming a lot at the evening times, because most of my students are around the US Eastern, starting at like 1 or 2 p.m. up to like 8, 9 p.m. Normally back to back, or with like an hour in between. So if I do stream, it's going to be in the mornings. At this point, I'm getting pretty busy when it comes to the evenings of the current students that I have. So if you need help, now you know where to find me. Look me up on Patreon. It's the Super Scholar. I'll add that to the link over here. Got there. Patreon.com. Man. Super Scholar. Right. It's a little bit funky over here. I like this. It's something good guitar string. Nice. I need to organize that a little better. Hold on. Can I do the background? Okay. Yeah, there we go. Cool. That's fine. A little bit better. So places you can find me, and the Patreon is where you can get actually direct help from personal student roster, if you will. Okay. So with that out of the way, kind of get to know a little bit me and what I do. Again, I teach a lot of mathematics, everything from basics in 5th grade, 4th grade, up to high school, trigonometry, geometry, statistics, calculus, up to college level differential equations, logic and organization, a little bit more towards the computer science space, right? I was a computer science major, so in that sense, I can support computer science based majors. But even then, I kind of stick to about maybe 2 years in the college space. I don't try to go any further than that because it's been some time. I can still help and assist. This might take me quite a bit of preparation for anything in the logic and organization or the bigger university level courses. But I do love differential equations. So if you got problems with differential equations, discrete mathematics, ooh, we'll have fun with those. Anyway, I'm back to the code. Back to this, but why am I doing nowhere? Oh man, I'm kind of jamming right now. Hold on. Mental break. Okay, so I gotta give this a length. Since we only have a static set of 8 LEDs, I'm gonna go ahead and make this 8. I think I can do a pend, right? I have to have so many adjustments. I just want to make it quite simple to work with, so until we get too advanced with the process, I'm just gonna do defaults false. That's 1, 2, 3, 4, 5, 6, 7, 8. So 8 LEDs, all starting from false, being a default turn off state. Okay, good. And then we gotta go into object has no attribute, get status, string LEDs. I don't need this anymore because I'm using this manually. So now the case is if right. So I need this to check each LED on the list. If it's equal to false, then we'll go ahead and turn it on, and also change this to true to indicate that status change. This is just a manual way to do it, right? But if LEDs are true, no, go back, are true, then we'll basically flip these around. Make them false. And this will basically go from beginning to end, turn them all on, then when it comes back to the beginning, it'll turn it off. And let's see what we do. Boom, boom, boom. Okay. Very good, very good, very good. Okay, so here's the next step. Speeding it up because this is boring. Let's go faster. Let's do 0.1. Yeah, look at that. And this is how your LEDs work in your house, dude. When you have those like streamers in the background, we got like LEDs working, do different designs, different patterns. It's based on this algorithm, adjusting that particular algorithm. Hey, Mr. Leopard Guy. Did you have fun fighting Scylla? Yeah, it was fun. I feel like I'm not that good at fighting them, but we had fun doing it. How you doing, Mr. Leopard Guy? Let's see. Hold on. I got chat in here somewhere. There it is. What up, buddy? We're doing some programming. You joining in for some programming? To be honest, we did very much struggle hard. Man, it was so close. We were like, it had like 30% left. Like 30% left, and we were so close to taking down Scylla. But you know what? Next time. She was hard, dude. That thunder jump and OP. The difference between the damage we got from her. Maybe the armor has to be better. Maybe you gotta enchant the armor. Yes, today we're gonna meet up in at 1 o'clock p.m. So be ready. That's why I'm streaming now, so I can get a little bit in the morning. But yeah, today we have a session at 1. Fractions, mathematics. Well, actually, what were we doing last time? We were doing graphs, so we're gonna continue with graphs, I believe. Yeah. You ready? Okay, so what else can I do that's fancy? Wait a minute, did it stop? Oh, it stopped at 100, right? So it does 100 loops. And you know what? That's kind of like a stopping point, but what if we just do true? And we just leave the break out of it. So we don't have an exit anymore, right? Just always true, while loop continues on forever, which basically means these LEDs will continue going forever. And that's how you basically repeat something. Now, the problem with this is that, the good thing about this is we have a 0.1 second timer between loops. I don't know if I want to do this, but what if we took this out? No, it's going absolutely bonkers. The thing is actually still working. I mean, look how quick it's going. You can probably measure the speed in which it's processing based on leaving off the timer, and this is its natural processing time. So again, computers think like thousands of, not hundreds of thousands of thoughts a second. So it's going fast. It's going real fast. But if I take this back out, because it doesn't even make any sense anymore. So if I go back and then change this to maybe 0.01. Oh, there we go. That's pretty. Anyway, I want to fight the next boss, Lux Trusaurus from Alex Cave's mod. Oh, so there's another mod. Okay. So lastly, create the mod pack. I will save that detail. So I will do that later. Just message me on Discord. Message me on Discord. Tell me this on Discord so it's saved, because in stream these chats don't get saved. So yeah, leave that message on Discord so I know what it was. Alex Cave mod. That's the one, right? Right. Okay, cool. Because I can at least look at it in Discord anytime. Here in chat, once I stop streaming, it's gone forever. So would work much better that way. Look at my fidget spinner. Look at it go, it's spinning. So there's a lot they went on to this one. While the task was technically just to turn one LED on, we kind of went ham and made a LED. Ooh, can we make it do police-like things? Like, can I make it like red and blue, red and blue, red and blue? There is a. I think you can change the value. LEDs, LED. That's cold air again. No, can I change the value? Turn all user LEDs. Input value set. Is there a way I can change the color type? Is my question here. Okay, number, proximity, set proximity marker, LED, set both proximity, LS. No, I don't think this one does it. I think this is just a red LED. Because the way you can tell is from this case, this is the brightness. 0 to 255 is brightness. If we had like a RGB, so 255, 255, 255, then we'd have the ability to adjust each 3 value sets for RGB. RGB stands for red, green, and blue when it comes to computers. So if we had 3 255 values, then I can tell you, hey, you could change the color. RGB would mean 0, 0 to 55. All right, cool. Thanks for the send. I'll take a look at it and I'll set it up for not today because today we're doing math, but next time we meet up for some Minecraft mods, we'll go ahead and I'll set it up for them. So yeah, it looks like it's basically just a 0 or 1, true or false. There's no in between here, unfortunately. Okay, well that's unfortunate. I wanted to make like one side flash blue and the other one red and do like a little police thing happen, but hey, that's for another time. Okay, that got a little too intense right there. All right, so what's my next objective? Because I've been effing around a little bit, farting around a little bit. Open the code track. Oh yeah, that little dude. Where's this little dude? With the button. There's this button. Where's that button? Where's that button? Where's this little dude, man? With the person button. Click the code track button below. Below. Where's below? I see people here. This isn't so fun. CodeBot connected. Okay, type this into the text editor. Click the person code track button below to learn more about the code for an objective. Oh, this dude! Really? Alright. This line gives you Python program access to CodeBot's hardware. You are importing from the bot core library, and that means everything. Yeah, I mean, that's kind of what we went through. And that's the symbol from bot core library imported. Yep, we got that. Alright, cool. Lit. Hey, you're writing Python code. Check the CodeBot in 3D view to see the red LEDs you've lit up. That's a good start. Ha! A start. We made that sucker do some fanciness. We did it like pros. Alright, great. Alright. There are 8 LEDs labeled 0 to 7. Byte means 8 bits, which are binary digits. 8 bits means basically 8 zeros or 8 ones. And binary means base 2, so the digits are 0 off and 1 on. You could use these user LEDs to display any number in binary. Oh, true. So creating binary now, we're basically going to be using this sort of binary interaction. Interesting, because it is a, given that you know how to convert binary to anything else, this can actually work out well. You could use these LEDs. I mean, yeah, now at this point we just set the specific values. Okay, but we'll continue forward next time. I'm kind of burnt for now, having to make our little bot do some fun, fancy things over here. Hey, look, we're on a table. We're in the cafeteria? Where are my computers? I had my computers. Oh. So there's our bot making some fancy LEDs going through. And I'm probably gonna end it here. hopefully you enjoyed what we did. Come back for more. We're going to go through the next sets of instructions, play around with the motors eventually, but these are long projects. These are really learning processes to understand what's going on with the hardware case scenarios, how to interact Python with hardware. And what we're doing here is basically creating a set of code. And while it's not directly connected to our little dude over here, right? It's not directly connected to the board, but potentially we can plug it in and drop this piece of code inside and then run it so that it basically does the code set that we've given it. This is essentially how any sort of development works. You create it on an emulator, simulator, test it out, then you get the actual physical device, drop in the code that you created, and it'll replicate the same instructions given. Cat, stop it. Scratching all my things. Anyway, so final thought here. Again, if you are wanting to learn more programming, again, I'll just mention it as per se, I can help, right? I have the ability to connect with you remotely. I've taught over 5,000 students, so in the end, I have enough experience to be able to teach all kinds of education, whether it's mathematics, 5th grade to high school, programming, if you're starting something, if you want to do game development. I have a great sense of beginning and getting you started, especially from the case of completely not knowing where to begin, guiding you through it, teaching you programming, making it entertaining. We basically do this exactly as it is that you see here, except I'm talking to you personally through our remote session instead of broadcasting to the internet. So given that you are interested in and you want to explore programming, you want to learn it, which it's gonna be a thing, man. Whether it's gonna be for the future of programming our little robots that are gonna do things for us, or if you wanted to create a game like an indie developer and make basically money off of it, these are components that require programming in the back end. You can design all you want, you can make as many 3D objects as you want, but in the end, those 3D objects don't do anything until you program them. You put some code to their movements, the angles in which their arms move, they swing, changing weapons based on code, the damage done, everything is code in the back end. So you can make pretty things, but in order to make them functional pretty things, that's where coding comes in. So I can help, whether it's just the professor office case where you have access to me, you send me information that you're having trouble with, and then I answer through image responses, through guided texts, anything like this. But whether it's on Discord, whether it's on Viber, whatever that messenger you basically use, you can communicate with me directly for $7 a month. But if you do need a 1-hour session or more, you can go for any of the next sets. Very popular right now is the 2-month or the 2 hours monthly. It's a very kind of base level for students. They come in, they just want 2 hours. 1 hour every 2 weeks is normally the case. We go through a session of learning, we go through some processes on where to begin, and then I give them guides to study on the way out, and they continue practicing, they continue creating, and then they come back with some questions on the next steps once they master the first 2 weeks. So on a lot of self-guided students that know how to basically do their own coding, basically not coding, kind of know how to learn by yourself, right? I can guide you on the step, and then you take the 2 weeks at home to continue those steps, and then we meet up once every 2 weeks where we go to the next steps, each step. So maybe first step would be variables, arrays, right? And the next step would be functions and classes and ways to control your program. Or in most cases, for mathematics, you may have run into trouble with certain subjects throughout the month. And given those 2 hours, well, you get the ability to connect with me anytime you have problems, and then we can go over those particular problems together where, well, we make everything make sense. That's the base case scenario. But for those struggling that need a lot more, there are other options. 4 hours remotely, 8 hours remotely. So 4 hours would be once per week, 8 hours would be 2 times per week. It really depends on how much the student is struggling, how much help you think you need, or how fast you want to excel in a particular subject. So if you want to basically go from nothing to a developer and you giving yourself like a couple of months, you can essentially go for an 8 hour, and from there we can speed everything up pretty quick. Depending on your pace, if you're just learning something for a hobby or you really want to grind and get that subject mastered. Those are just the cases on how this works. So that's it. You can find me on Patreon. Of course, you can basically do a lot of different things here. You can check out what I'm writing about. I like to write articles about economies, about markets, everything happening right now, government shutdown, job cuts, and all this kind of stuff. If you're more of the upper age, to my age, to my generation sort of people, you'll enjoy these kind of sets, and also some technical IT journal stuff on how to install DeepSeek AIs on your computer, how to secure your computer, how to find some open source software to help you basically run some stuff, security software to run stuff. Basically, there's a plethora of I've existed on the internet for so long as a techie. I kind of know all the ropes left and right. So normally, do I pay for much of my stuff? No, I use free options that I can secure my computer, free options that I can use an AI on my computer, and then on top of that, as a programmer, I can do even more with that skill attached to those AI components or security components or whatever. So everything I do manually. But again, in the end, most people are users and they just want to go pay for security and depend on it. But I do everything manually when it comes to a computer. Anyway, and if you want to know this kind of stuff, that's essentially what I teach also. If you want to secure your computer, secure yourself, basically a lot of subjects that I can cover. Anything from academics, mathematics, programming, building computers, securing computers, networking, creating internal networks. I can go on things we can learn, but it's all depending on the student's interests, and based on your interests, you can really specify what you want to go forward. Anyway, that's it for today. Thanks for joining, Mr. Leopard Guy. Appreciate you, bud. I will see you in 3 hours. So prepare for the math. We're gonna be doing some mathematics. I hope you're ready. Yeah? Yeah? You ready? You ready for the math? You ready for the math? Are you? Are you? Come on. Give me a little yes. Give me a yes. Are you ready? No one's ever ready for the math. But it is one of the things we want to go through. Always. Once you know math, man. Oh yeah, see ya, bro. Once you know math, it kind of gets easier, right? So that's why I always promote, come through, go to my Patreon, sign up even for free just to keep in track. There's a lag when it happens with the chat. So, man. I wish there was no lag. I wish it was instant. We're in the future. We should have instant internet connection, no lag and everything. But hey. But yeah, check out my Patreon. Keep up with some current market stuff. Join for free if you want to keep in touch. You'll gain access to my Discord, my Stoat/Revolt Discord servers. That's for free. You just sign up and you get access to those locations, and you can still get in touch with me there. But if you do need actual help, definitely think about going for a membership where I can teach you. Again, for as little as $7 a month, you can send messages to me, images, and whether it's math, programming, whatever, I will respond with those particular adjustments, helps, pieces that will help you understand what's going on. Or if you want an actual hour session, where we can go connect Zoom, Discord, wherever is comfortable for you, one-to-one, we can directly connect, and then I can teach you from there. And that's it. And there's more, of course. 1 hour, 2 hour, 3 hour, 4 hour, etc. So you can kind of pick your choice there. Anyway, I'm gonna go relax a bit because I got 1, 2, 3, 4 students later. Next Saturday is crazy. 1, 2, 3, 4, 5, 6, 7 students on a Saturday. I'm not gonna have weekends soon. I thought I had weekends, but that's gonna be it's gonna be gone soon. A A lot of students needs help lately. And honestly, I blame AI. I've had a lot of students that depend on AI, and it's a great tool to explore, but it's not a great tool to learn because most students like to copy and paste information from AI and don't take and absorb it and really like dissect it, really take a look at the AI's response and trying to figure out what it did. They're like, oh, okay, the answer is 10. And then they put 10. So AI is great if you use it responsibly. And again, there are ways I can teach you how to really use AI to your benefit, how to code it locally with Python. Just find me on Super Scholar, ChrisMIA, on Patreon, ChrisMIA on most places. You can see all the links here in the bottom left over there. Let me kind of move that out of the way now. Where's the browser? Browser. Nope. There we go. You can find me on any of these locations. I'm streaming on Rumble. I'm kind of liking Rumble right now because I can multi-stream. I can set up a multi-stream from Rumble to X, YouTube, and Twitch at the same time, which is super cool. I had to use third-party software for that, but Rumble lets me do that directly. So that's fancy. So I'm going to be doing Rumble-based streaming as well. But you'll catch me on YouTube, you'll catch me on Twitch, you'll catch me on X, whichever place you prefer to go to. Keep in mind, trying to be as diverse, as accessible as possible, and do come to streams and ask questions because I do read chat as best as I can. Sometimes I might be in a particular thing and be kind of distracted, which happens when you have ADD, unfortunately. But I do check on chat, make sure that I respond. I get a good I got a good decent awareness. It's not instant until chat's popping like crazy. Like I have to look every time because there's new messages all the time. Sometimes it's quiet, then someone comes in, like Mr. Leopard guy comes in and says hello and interacts. Then I'd be like, oh, okay, hey, what's up, bud? But I do this again for most case scenarios just to be educational, to teach, to have an open forum for anyone to come in, ask questions. If there's no questions, I just freeform. I just go into the details of whatever the subject of today's video is. And today was Python and using it to control objects. In this case, it was a little CodeBot, a little RC car with a chip inside. And we saw how to control the LEDs for now. We'll learn how to work with the wheels, work with all the other mechanics of that device in the future. So I'll take my time, I'll go into detail, answer any questions, like and subscribe, join the channel, join my Patreon, and ask questions when we're on air, when we are on air live. And I'll be happy to answer. It'll be a part of the process too, so I'll be able to not only answer Chicken Johnny 6'7". So many memes. I do have, I think, one of my students that says 6'7" all the time today.